Good evening and welcome to my first online math lesson for the Flipped Classroom for Math 95. My name is Mr. Burke, and if you are watching this video, you should be watching your first lesson in section 7.1 for the Flipped Classroom in Math 95. We're going to begin by looking at section 7.1 by looking at how to simplify rational expressions. And basically what we mean by a rational expression, it is simply a fraction written in this form. And we're going to begin by looking at question 24 from the textbook. So this is written as 7a to the third over 21a. And what we do to simplify this is we try to reduce the numerator and the denominator in all the possible factors that are present in the problem. For example, let's consider the numerator. I can write 7, well, 7 is a prime number, so I really can't do much with that other than to leave it as 7. A to the third, however, I can express more simply as a times a times a. For the denominator, I can take the value of 21, and I can rewrite 21 as a factor of prime numbers. So one strategy I can do is I can take 21 to the side, and I can rewrite 21 as the product of 7 times 3. And because 7 and 3 are prime factors, I don't go any further with my factor tree. So I'm going to go ahead and write, in place of 21, 3 times 7. A, I can't factor any further. I'm going to go ahead and just leave that as A. So now we're going to look to reduce the problem, and we're going to see what is the same at the top and bottom and reduce. So I have a 7 on the top and 7 at the bottom. I'm going to reduce those. And I have no further numbers to simplify. So on the top, it's not like there's nothing left there. We always do have a 1 present. We may not always have to use that 1, but I put it there just as a reference while we're introducing this so that until you get comfortable with it. Next, we have to look to see how many a's are in common between the numerator and the denominator. So in the top we have 3 a's, in the bottom we have 1. So we're going to reduce this by getting rid of 1 of each. And now we're going to have on the top 1 times a, or simply a times a to give us a to the second. On the bottom we have left simply 3, nothing else. So the final answer to simplifying 7a to the third divided by 21a is going to be a to the second over 3. So that is our first rational expression that we've reduced and put into simplest terms. Next, we'll take a look at question 26 and try a similar question here with that's a little more robust. So this is going to be 8 y to the fifth times z over the quantity of 4 y to the ninth times z to the third. Again, I'm going to break this down and reduce all of the terms or all of the pieces of each term in the numerator and the denominator into its simplest factored form. So 8, I'll put that over here. I can write 8 as 2 times 4. I leave 2 here because 2 is a prime number. I cannot reduce it anymore. But 4 I can reduce further and making that 2 times 2. So I will write 8 here as 2 times 2 times 2. Y to the fifth, I can write as y times y times y times y times y. And then z I can simply write as z. And I only have 1. For 4, we already know from here this reduces into 2 times 2. Y to the ninth. This will be a little long, but it should make the point for how this is done. I will go through a simpler way of doing this in a moment. I have y times y times y times y times y times y times y. 1, 2, 3, 4, 5, 6, 7. I need 2 more. Times y. We still have 3 z's down here. And I'm going to have to kind of squeeze these in because I did not leave myself quite enough room here. So when I look to see what I can reduce, I have one pair of 2's, another pair of 2's. This 2 will remain in the top of the numerator. So now I have how many pairs of y's? I have 1y, 2y's, 3y's, 4y's, 5y's. No y's remain. So I have 1, 2, 3, 4 y's remaining. In the numerator I have 1z. Down here I have 3 z's. So I'm going to cross out 1 z in each place. And in the denominator I now have 2 z's in its place. So to simplify this, let's see what I have left. For the numbers, I have a 2 left in the numerator. I have no y's left. I have no z's left. So the top will only be 2. In the denominator, I have 1, 2, 3, 4 y's. That will produce for me y to the 4th. I also have here z times z, which will simplify to z to the 2nd. So writing my answer more concisely, this will give me an answer of 2 over y to the 4th times z to the 2nd. And this is the simplified version of this rational expression. So we have taken this rational expression, and by reducing all the possible factors that are in common from top to bottom, we have expressed this rational expression now in lowest terms. Feel free at any time to pause this video if you want to consolidate your notes or even go back to review this again, as we are going to look at one more question. Actually, we will go on to the next part of this where we begin to do a little bit of different types of factoring. 28. So we're looking at on question 28. That is in page 512 in the book. And the question looks as follows. 3a plus 12 divided by 3. So, when looking at a question like this, it's not a monomial over a monomial, or one term divided by one term. We do have a monomial on the bottom, that is 3, but on top, we now have 2 terms. And when we talk about 2 terms, this is a binomial. And when we're looking at factoring a binomial, or having to possibly factor a binomial, the first type of factoring that we're always going to look to do is what's called the greatest common factor. So I take a look at 3a and I take a look at 12. And I try to identify what factors 3a and 12 might have. This has an a, this does not have an a. So there will be no common factors that will be variables between the first term and the second term in the binomial. However, since this has a 3, and as most people know, we can write 12 as 3 times 4. We can say that this binomial on the top has a common factor of 3. So what we're going to do now is we're going to factor out the greatest common factor, and we're going to express that now as 3 times a plus 4. We will rewrite the 3 at the bottom. Now that we have 2 factors at the top, the factors being 3 and a plus 4, and we have the factor of 3 at the bottom, we can reduce these by reducing the 3's and leaving us with our final answer of a plus 4. So we have taken the rational expression 3a plus 12 divided by 3. We have looked at 3 as a factor in each of the 2 terms of the binomial on top. We have factored the 3 out, and because 3 is multiplying the quantity of a plus 4, we can take the 3 in the top and the bottom, reduce it, and leave simply a plus 4 at the bottom. You could write it over 1, but that will not be necessary. Let's consider another problem that will be a little more robust. Number 30. We have in the rational expression 4y squared minus 20y divided by 4y squared plus 12y. In this rational expression, there may be multiple methods of factoring that you may need to utilize. There may, then again, there may not. So these are just things that will need to be looked for. For example, we take a look at 4y squared minus 20y. For the 4 and the 20, the greatest common factor for 4 and 20 is going to be 4. So we are going to factor 4 out of the binomial here. For y squared and y, we know that y is common between these two, so we're going to factor y out of this. What will we have left when we factor 4y out? Well, 4y times what will give us 4y squared? Let me demonstrate this up here. Here I'm rewriting the greatest common factor. 4 times what is 4? That's 1. Y times what is y squared? Well, y times y should give you y squared. So I'm going to put that over here. Minus. 4 times what is 20? That's going to be 5. So 4 times 5 will give us 20. Then y times 1 will just give y. So I'm going to go ahead and write this as a negative 5 here. Now, let's do this work again, and then we'll put this expression here. We have 4y squared plus 12y. Well, for 4 and 12, the greatest common factor will be 4. For y squared and y, the greatest common factor will be y. 4 times what is 4? Well, 4 times 1 will be 4. I won't put anything yet, as we'll probably have something else there in a moment. Y times what is y squared? Y times y is y squared. I could put a 1 here, but it is not necessary to do so. So this would be 4y times y will give me 4y squared, so I know that is correct. Well, let's see. We'll bring down the plus now. 4 times what will give me 12? That will be 4 times 3. That will give me 12. And then y times 1 will give me y. So just to check, 4y times 3 will give me 12y. So we have now factored the denominator to yield this. So this will be 4y times y plus 3. So looking at this now, we have 4y times y minus 5 over 4y times y plus 3. The binomials, in order to reduce them, would have to be identical. Both the first term, the second term, and the sign between them. We don't have that, so we cannot reduce these. However, we have a 4 that will reduce and a y that will reduce, so we can reduce these. And this should yield us the answer of y minus 5 over y plus 3. And this is the original fraction expressed in simplest form. I will take one more problem before going on to the next section, and we're going to take a look at question 34. This is going to be 6 minus 5a over 10a minus 12. Now, looking ahead to this, I see a property that is going to come up that I will briefly review with you. But let's see what we can factor. When looking at the numerator, 6 and 5 have no common factors, and only the second term of the binomial has a variable. So no variable will be factored from this, and as a matter of fact, the top is not factorable in any way at all. However, when looking at the bottom, we can see that between 10 and 12, we'll have a common factor of 2. And we'll go ahead and factor that out and see what we get. So 2 times 5 will give us 10, and then we bring the a down, minus 2 times 6 will give us 12. So we can rewrite the bottom now as 2 times 5a minus 6. On the top, we have 6 minus 5a. Now, at first looking at this, one might say, well, there's no 2 to reduce with at the top that's a factor, and these two terms are different. However, there is a property that you need to be familiar with in mathematics for factoring, such that when you have the quantity of a term, a minus b, divided by b minus a, this is always going to be equal to negative 1. This property will be further demonstrated in a review that I will offer on factoring. So in this application, if we look to see where this applies, we see 6 minus 5a, and here we see 5a minus 6. We have the 6 is switching here, the 5a is switching here, just like this. So this whole property will reduce to -1. So now you could write the negative of this on the top, as so, but most often you will see the answer expressed with a 1 on the top, the 2 at the bottom, and the negative written in the middle. So when you have 6 minus 5a over 10a minus 12, when reduced and put into simplest form, it will be reduced to -1/2 as a result of using this property. This is the first of, I think, 4 to 5 lessons that will cover Chapter 7, Section 1.